Hello YouTube, and this is Amy version 2 that I was testing in my last video. Now I had it on a power supply at 25 volts or so, testing some software I had running, and suddenly it was drawing 180 milliamps, which was the current limit of the power supply, and it was making a very loud buzzing noise, which I think was from this DC-DC converter. So I have a feeling this pico is the second one I've had go short. So in the first one I had, and I can link the video in the description, this DC-DC converter here and this inductor went short circuit and sort of melted itself. So I'm going to have a look, do some resistance checks and see if this one's done exactly the same thing. Now if you measure here on the input pins, with the power pins, these pins go straight into the DC-DC converter. We are getting 90-ish, 93k, which is fine. That's kind of what you would expect. So let's measure the input of the pico itself. So there we are, we're measuring from ground to V-bus, which is the 5V input pin. And we are getting 3.6k. I think that's kind of what we were getting on the other pico when it blew up. I'm not sure. Let's try it on the other pin. So this is, what's that one? No, not that one, that's ground. That one. Right, so that is there, ground and VSys, or V system. So that's after the diode and just before the DC-DC converter. That should be hundreds of K or 100k or something like that. That is not good. That will give you a very high current reading. So that's the problem. So again, it looks like we've had another pico go bang. And I'm not sure why this should not work. It's because we've got high voltage here. So we've got, let's say, 30 volts. I mean, this DC-DC converter is rated for 36 volts. So that should be absolutely fine. This drops it down to 5V. And it just feeds 5V straight in to V-bus, which then goes through this diode into the DC-DC converter. This DC-DC converter is rated for a voltage between 1.8 and 5.5 volts. So supplying 5 volts on this pin, and then you got the diode drop, it should be absolutely fine. But for some reason, I've blown up 2 of these. So unless there is some weird problem that no one else is having with picos, something here is blowing it up. So what I'm going to do, I'm going to put a scope on the end of here, measure the output of this, and see if this thing's noisy or if it's got transients on it that's causing it to damage the pico. It's very odd. So I've soldered some wires on the board. I've got measuring the input and I'm measuring the output of the DC-DC converter. On the scope here, I've got it all set to trigger. So I've got the pink line on the input, the blue line on the output. That's just noise, probably from the lights or something that's showing up on the scope at the moment. So we're going to apply power. I'm going to apply 25 volts. I'm going to increase, I don't really want to blow it up, do I? We'll keep the current limit set as it is, and we'll see what happens. So I'm going to film this as I flip the switch. And already we have quite a lot of noise on the scope. That's the output. So let's zoom in. I'll do that off camera so that in case anything happens. What have we got here? Crikey, that's a lot of noise. Oh no, here we go. Here we go. Let's set the trigger. I'll stop that and we'll turn it off. So we have a voltage there of 2.88 volts. So there's nothing there that should suggest it should work. Of course it's oscillating like that because it's basically running into a dead short. So I don't know why this wouldn't be working. It's not like there's a massive peak or anything like that that's going on. The input voltage there is being current limited, as you can see. So we'll try that again. We'll remove the current limit. I know it's going to probably go pop, but what we've got to lose. Right, so I try again. Camera is rolling, And switch is running. Oh, what's going on? Oh, it stinks. And we have some smoke being released again from the DC converter. Brilliant. So I think that is kaput. And if we zoom in on the scope, what do we have here? Well, again, there's nothing amazingly obvious. Right, I'll pause the trig, pause the scope, and then have a look. And then power off. Right, the scope is looking like this. So we have again, nothing particularly amazing. So we go back into cursors. Excuse me, because I'm doing this looking for a camera screen, so it's a bit tricky. So that one, channel 4, we are looking at 2.4 volts. Again, it's being clamped because we're going straight into a short. And we go into channel 3, up to there, oh, that way. And we are looking at, again, there's our supply, again, completely unclamped, 26 volts, which is what we've got set in the scope. So that's what we'd expect. This one is being clamped. So, yeah, bit strange. So because we definitely know the DC-DC converter has gone kaput again in this Pi, I'm going to remove this diode because that will take it all out of circuit. Then we can measure the output straight from the DC-DC converter, the first one. And then we can see if there's any spikes or anything on there that could have caused this one to blow. So with diode removed, we have on the scope. Oh, that's interesting. Let's zoom in and take a closer look. So this is our 5-volt rail. I'm going to get a pointy thing. So this is sitting here nicely along this line here at just a smudge over 5 volts. That's absolutely fine. We've got this peak here that's sitting at 5.8 volts. It's very short because you've got a bit of ringing on it. But is that enough to kill it? Is that really going to be enough to kill it? Because it's rated to 5.5 and we're putting 5.8 in. I can't see it. I mean, it's got to be. But I don't know why. And I wonder if maybe a bit of capacitance on the output would fix that. Strange. Of course, this is with no load. Yes, I know it's fitted poorly, but with the resistor and a cap across the output of the converter, I'm still getting the ringing. So I can't believe that would cause it to blow. I really can't. I mean, there's quite a lot of ringing there. But of course, these are the high points. If I set the trigger in a bit lower, see, that's the average ringing that we're getting. We're just getting these odd high ones that we're triggering on. I don't know if they're harmonics or anything. Yeah, opinions in the comments. Is that enough to blow up a pico? Apparently it is, because it's a 5-volt input. I'm supplying 5 volts with these tiny peaks on it. Well, they're not tiny. They're about 0.5 millivolt either side, but it's rated for it. So yeah, thoughts, opinions in the comments, please, because this one's sort of stuck me a little bit. Right, I'm going to carry on playing, so I'll see you later. Right, bye.